Hi, good morning, everyone. Let's get started. A struct, we already saw that actually. In fact, we have already observed that. But for your understanding, a struct can also be given as a can be created as a variable directly. It is not necessarily that you have to create it as a type. You can create it as a variable as well. If it is a variable, definitely you cannot directly attach any methods to it. You can add functions and stuff like that, but you cannot attach any methods. What I mean to say, I will explain it. We cannot attach any methods to it directly when this is a struct variable. Okay. What do I mean by is, let's say I create a variable called p1. The type of the variable is struct of name, email, contact number of string. This is the type of the variable. That's a good thing in Go actually. Go type system is pretty flexible. One of the best features, even though Go is not 100% object oriented. Go is not purely functional, uh, not only functional, not object oriented or not procedural. Go has is a different category we can put it into. So I always call it as a hybrid. It takes the features of different things and it has its own features as well. The features that in Go you don't find in other programming languages as well. Okay, you can do whatever you can do almost in object oriented. Of course, the concepts are not polymorphism or it's not encapsulation. It's not object oriented uh, classes, inheritance, and all. But the final output, whatever you get it, you also still get it using Go language. Okay. However, things you do in functional programming, writing pure functions, passing functions as arguments, writing closures and etc. Go. We can also write pure functions, without any objects and all. Like in procedural oriented, you can do like writing functions and then executing things like functions without attaching any creating any methods. You can do in Go. So Go is the Go is kind of a hybrid. And when you come to type system, generally you take any type system in mostly object oriented programming languages. Every type is derived from the another type. Okay. Like every type in C sharp, every type is derived from system.object. In Java, every type is derived from, I think, java.lang or something. Uh, so there is a hierarchy. That hierarchy has to be maintained. But in Go, actually, there is no hierarchy. There is no concept of inheritance. There is no hierarchy. No hierarchy has to be maintained. Okay, no hierarchy has to be maintained. But the type, this is the flexibility you get in Go. This is not only a type, you can create it as a variable as well. So that means, how do you assign values to this p1 equal to struct of and directly give values? Name is Jitin and then email is jitin@gmail.com and then contact number is, if you look at it, it's a variable. It's just a variable. It's not a type. Even in the previous example, even though we are giving, if you go for this example, we are embedding it as a type. Still, it is where is it? It's inside a type. Person is a type. Address is, even we have embedded a struct. It's part of that. It's a type. Okay. But when you look here, it's just a pure variable. P1 is a variable. Many things in struct in Go we can create it as variables. You can create it as a variable of uh, a type like this struct. You can create a variable of a function. A function can be created as a variable. That's one of the beauteous things. A function can be created as a type A function signature can be created as a type. A function can be created as a variable and assign a function. A struct can be created as a variable. A function struct can be created as a type as well. So different things you can do. So here we have created it as a variable. Okay, this is just a variable. How can you attach methods to a variable? Probably we cannot attach a method to a variable because it's a variable. Okay. You can create a function as a variable as well. I'll show it later. But right now we have not done any kind of a anonymous functions and all that we don't do. But later on I will show you one example. Okay. Then let's say I want to display the details. Let's say I create a function, maybe display. Okay. What you got to display? I got to display a person of this because that is what the type is, and then I can display the details. So here you are supposed to pass a variable which is of this type. The whole thing is a type. So hence you can call display. So you can call display of P1 because P1 is satisfying this particular. P1 is a type of this. It has printed all the details. It has printed all these details. Something like this. Okay. This is like a variable. Cool. And there is a concept. So whatever we have discussed, actually, we started with a normal struct. We created a struct with anonymous fields. That means int, string, and all. We have seen the difference between type with equal to operator, which we are going to create a alias and then creating a new type. The difference we clearly observed, and we used a concept of composition. Composition concept we have done. Third one. And then we also saw that how can you use promoted fields. Promoted field is a concept. We did see how to create promoted fields for this struct. And we see that how can you create embedded a struct by directly creating the struct by using embedded struct. That is something. And we saw how do you create a variable something which is of type any and then gives different types to any and then deal with it. That is also we have done. uh, and then this one we also observed that how do you create a struct as a variable directly without creating it as a concrete type. You create it as a variable and then assign the values to that particular variable. That also we have done. And the last one with this particular concept, we will see more. We have to see more about user-defined types. But I'm talking about the structs kind of the thing. Sometimes you need struct just to attach methods. You need struct just to attach methods. That means generally a struct without any fields. Okay, it looks pretty interesting. It looks pretty confusing as well. Why do you have to create a struct without any field? Okay, still it does make sense. Let us say that Go doesn't support any kind of polymorphism that we are well aware of that, but if at all you come across a situation where the same method with the different signatures you would like to implement, still the concept is pretty clear. Go says that are you short of any names? The concept in Go is why do you need a polymorphism? Are you short of any names? Yes, we are not short of any names. Okay, we are not short of any names. Yet we can create an empty struct and attach methods to that. What do I mean by empty struct? I create a struct. Let's say S1 is my struct, which is of type struct, but no fields. There are no fields here. Similarly, I create something called S2, which is also empty struct, no fields. Let's assume that I want to create a method called area. Okay, I want to create a method called area with two signatures. I can create rectangle square, but for example, you come across with the two signatures. Function S as S1 of area, maybe L and B, and also I can create something called area because both of them are S. That's the reason I do. You see that is here. Even if you give the same signature as well, because it's a different attachment, the receiver is different. One receiver is for S1 and the other one receiver is for S2. If you clearly observe that, let me give it as a pointer. If you clearly observe that there is nothing inside the struct, when the struct has nothing inside it, generally there is no memory is allocated for struct. For variable S1, there is no memory is allocated. Okay, that means where S1 is S1, okay, and then where S2 is S2. So I can say area 1 is S1 dot area of maybe some values, and area 2 is S2 dot area, which is uh, some value. I'm sorry, what is this? 45? Something went wrong with mine. So you got area of S1 and then area of S2. Absolutely, if you look at the size of S1, because the size of a structure is always based on the fields inside the structure. The function is different. Whenever a function or a method is created, the size of the function is based on the input parameters of that particular function because a stack frame is created with respect to that particular function. Okay, yeah. Come here, A1 and A2. you have got A1 and A2. If you look at the size of A1, fmt dot println size of S1, not A1, unsafe dot size of S1. Similarly, if you look at the size of S2, the size would be zero basically. The size is zero because the struct doesn't have any size. If you really look at it, the struct doesn't have any size because there are no fields in the struct. You know how many times you passed a message just with a missed call through your mobile? We used to get, particularly the telephone days, whenever we are using telephone. My friends used to give me a missed call, two missed calls. That means, yeah, I'm going to. They're asking me to come out from the home, maybe to play some cricket, to play cricket. They used to give me three missed calls to pass some information. Their missed calls used to be, used to have some information. Yeah. Still, it is not a call; it's just a missed call. Yet it used to pass some information. Sometimes you say, once I reach home, I'll give you a missed call. You're traveling somewhere, you don't need to make a real call. You just with a missed call, you can pass some information. Just with a missed call, you can pass some information. Okay, how can you pass some information just with a missed call? The reason is pretty simple. You know that what the missed call contains, from whom you got the missed call. Similarly, an empty struct without any size, an empty struct without any size, because the size is zero, can attach methods. Actually, the methods contain some memory because the input parameters. Any method contains memory, consumes memory, consumes memory. Uh, the reason is based on the concept is based on the input parameter and the return type. Here it is 4 and 4 bytes, and then another 4 bytes, 12 bytes. This function, this method, it consumes totally is 12 bytes. But the S1, which is a structure, it doesn't consume any memory. Okay, let me go and then create. Uh, okay, fine. Let me go and create S3, which is of S1. You see that S3 is what? Actually, S3 is a pointer of S1. What does S1 contains? S1 contains nothing. So what is this address of S1? Address of another S1. You're creating a new variable, okay, which is of S1. Okay, that address is given, that particular pointer variable address is given to S3. So S3 dot area you can have, because however area is your, it's a pointer receiver. Okay, S3 dot area, I call it like this, S3 dot area, with A3, you know, and then S1 using S3, which is called A3. If you look at it, so this is very, very interesting actually. This is very interesting. S1 doesn't contain any size. If you look at it, S1 doesn't contain any size. Any variable that you create with S1, it doesn't contain any size. We already knew here. So what address it gives is pretty interesting thing. What address it gives? Okay. We can print the address and see what address it gives. Okay, S3 address, fmt dot printf, address of S3, that means actually the S3, whatever the address that S3 holds, P is S3. You see that? Whatever the address, because S3 is a pointer, it holds address. What address it holds? It holds the address of S3. Similarly, I create S4 from S2. Okay, I give A4 equal to S4 dot area of some area, and I want to see what address that S4 holds. If it consumes some memory, it has got an address generally. Let's say I have created variable num1, which is of integer. Integer is 8 bytes on 64-bit machine, so num1 has some address because it takes 8 bytes of memory. But here it doesn't contain any memory. This doesn't contain any memory. So what address it gives is a very interesting thing in Go. This is the address. You see that the address of S3 and the address of S4 are same. That's very, very interesting thing actually in Go. So address is given based on the allocation. Address is given based on the allocation. But what it allocates nothing because there is no memory that has to be allocated. One more thing, I create something called where S okay S5 equal to new of S1. You know what the new built-in function does? Let me create A5 equal to S5 dot area of some area I give. Okay, for the sake of just printing, I would sorry. Again, I'm printing the address of S5. See this. New function is supposed to create a new instance, new address, and assign the address. So 3 S3, S4, and S5, S3, S4, and S5 are giving the same addresses. So the concept is pretty simple. Whenever you create an empty struct it doesn't hold any memory, it doesn't contain any size, it has got zero size. So go create some dummy addresses. This is essentially a dummy address. We have already observed even for the slices ones. If you remember that, we create a slice. Let's say here I create a where sorry slice one equal to yes, it's not nil. We already knew that it's not nil. That means how can it not be nil? Because the pointer inside the slice, the pointer, because slice header contains the pointer, length, and capacity. the pointer is contains some address. Let's say I create slice 2, which is again integer. Again I create slice 3, make of 0. See, 3 slices. None of the slice is nil. The reason is the pointer is not nil inside the slice. How could be the pointer is not nil? So if you really look at it, when you use the uh, unsafe pointer and then get what address that slice 1 inside the first field pointer contains, slice 2 inside the first field contains, slice 3 inside the first field contains, you know the concept. The concept is pretty simple. I take the slice header, let me take it as ptr1 equal to unsafe dot pointer of uint_ptr of address of slice 1. Again, unsafe pointer you have to take. You take slice 1, take the unsafe pointer and convert it to uint_ptr, and that is passed as the unsafe pointer over here, and you get actually three integers ptr1. You get three integers. Ptr1 is actually the array of three integers. If you print the address ptr in slice 1, ptr1 of 0, you want to get the length. We already knew this. Let me comment it aside. This is the address. You want to print it in hexadecimal format. You can give it as printf slice 1 percentage p printf percentage x in a hexadecimal format. I printed. This is the address. Okay. So what exactly I did? I take the address of slice 1. Any pointer can be converted to uint_ptr through unsafe pointer. Any uint_ptr can be converted back to the pointer. Any pointer can be converted to the original structure because it contains 3.3 variables which is of type integer. That means 88 bytes. We do the same thing with pointer 2 with the slice 2 point 2 point 2 point 2. We are taking actually pointer array slice 2 slice 2 and also take something for slice 3. I give it as pointer 3 Okay. You see that slice 1 address is same inside the pointer, slice 3 2 address is same, slice 3 address is also same. That means the header I'm talking about. If you don't follow the slice concept and then pointers concept, probably you may not be able to understand this. So the concept is, the whole thing I'm trying to explain is, Go creates the dummy pointers, some placeholders, dummy pointers. Actually, these are not real pointers. This is zero. The size of this are zero actually. No elements in the slice, zero. Slice 2 is zero, slice 3 is zero. But there are three different slices. Similarly, S2, S3, S3, S4, and S5 are also three different structures, empty structures, which is of type pointers. See, the address is same. That means Go create some dummy addresses. It's the concept is pretty clear. Go doesn't want to complicate it because if when there is no size, what do you give? There is no size, no memory is allocated. But how can you say that this is not nil? The reason is it creates some dummy address. It gives some dummy address and say, hey, this is not nil. The reason is it contains some address. In fact, you can do for S1 and S2 as well because even though they are not pointers, they are variables, but you can still get the address of them by using address of operator, of course. S1 and then S2, you can use uh, address of S1, not necessarily to be pointer, address of S2 because it contains an address. See, all of them contain same address. So the concept is very, very clear. When does a variable contain some address? When a variable contains some memory. But if it is an empty structure, it doesn't contain any memory. It's an empty structure. Empty structure doesn't contain any memory because we all clearly saw that what is the size of S1? What is the size of S2? The zero, zero. The size is zero. When the size is zero, there is absolutely no memory it contains. Still, in order to pass it as non-nil, Go create some dummy pointers. It gives some address. So legally the variable is valid. This is not nil. This is not S3 is not nil. S4 is not nil. And S5 is also not nil. It contains some dummy pointers. Why I explained this concept is this is also similar actually. This is not nil. The size is length is zero. The capacity is zero. Length is zero. Here the length is zero. Even then, when the lengths are zero, that means there is absolutely no underlining array that is assigned to slice 1. There's the pointer to the starting location of slice 1 is it's not valid because there is no length. Generally, you need some money to open a bank account. Okay, why do you need a bank account? To keep some money. But you know that there is a zero bank account India started. That means you don't need to keep any money, you don't need to deposit any money, you don't need to even spend a single rupee to start a bank account. It was one of the initiatives that Indian government has taken. So absolutely no money that you need to deposit, you need to give, you need to spend in order to open an account. Still, it is a valid bank account. Similarly, no memory is created over here. Still, these are all valid variables. The reason is internally Go create some dummy addresses. Okay, this is what the whole concept of this.
Any
What
question?
about the structures? And then I think we have gone through almost everything with respect to structures. But user-defined types is not yet completed. Now we go to the next example, 46, user-defined type. One of the most compelling feature in Go. I like this feature. You know, in Go actually, you create a variable. Unlike many programming languages, particularly the object-oriented programming language, you don't get any methods that come along with num. You know, maybe something called to string or to hash code, get hash code or something like that. You get some functions to equals or something. You get some methods because every variable. I'm talking not in Go. I'm talking from other programming language perspective. Every variable is derived from a type, most probably some object type. That type contains some methods. So every variable you create, so you get some methods. But Go doesn't follow any inheritance concept. Go doesn't encourage you to create any inheritance concept. But how can I extend types? Is you can always create a type from an underlining type, from any type, whether the type is created by Go or the type is created by you, which is a user defined type. You can always create a type from an underlining type. So I'm creating a new type. That's the reason I always say user defined types. I don't say structures because you can create user defined types. This is a user defined type mind. Mind is of what? Mind of type integer. So you can create variables for mind now. So what is the use of it? Is the use is pretty simple. When you create your own type, you can attach methods. Let's assume I create a method for my int which is called to string. Return fmt.sprint, because anything that you pass to a sprint, any variable, any literal you pass to a sprint, it is converted as string. It's as simple as it is. Anything that you pass to a sprint, it is converted as string, with respect of whether it is integer, it's anything. So I just written a sprint. Otherwise, this is quite complicated. How can you create it? It's not complicated, but if you not don't want to use it, then what I have to do, return strconv dot integer to ASCII, but you have to pass the integer value, so you need to typecast to int of m, because here it is expecting you to pass integer, but this is not integer. M is of type int, so you need to typecast it to integer and return it. Instead of this is even very easy approach. Now my int contains a method which is called to string. Let's say I create n1 is my int equal to some value. Num1 dot to string. Str1 is of type string because num1 has got a method which is called to string. So num1 dot to string. It's just a type, did nothing, just printing str1, but it is of the type string. Remember that str1, it has converted num1 to string because we have created a method called string. We have created a method called string. By using that method, we have returned it as a method. We call that method and return it as a string, and that's what num1 is. Okay, what can be typecasted? Anything that can be typecasted to integer. You know that there are some typecasting rules. Not everything can be typecasted to integer. As a boolean cannot be typecasted to integer, but any number type, number types means it could be of uh, it could be of uh, float, it could be float 64, it can be any type of concrete number. All these types can be converted or typecasted to number, right? Any type that can be typecasted to integer, or any type that can be typecasted to integer that also can be typecasted to main. The rules are as simple as it is. So technically what happened is I create a variable of num2 which is of integer, and I pass some value. Okay, I can call to string function over here. How can I call num2 dot, you don't get to string because to string method is not on integer, to string method is on type maint. So this can be typecasted to maint and then call string method to string method. Similarly, I create a float because a float can be typecasted to integer, so it can be typecasted to maint as well. But you lose the decimal points. That's a different thing. Maint of float 1 to string str3 because a float can be converted to string, and hence a float can be converted to int, so it also can be converted to maint. If you create a boolean and then I would like to convert it to string, you cannot convert it a boolean to maint because a boolean cannot be converted to int, and hence it also cannot be converted to maint. Fine. Just for your okay, I create another type maint2, let me name it as 1 of integer. I create another method maint2, let's say square. which is going to return integer, or my int 2, you no issues. Return int of m into n. You perform n into m, and then you need an integer, you convert it to typecast it to integer. You're returning it. My int 2 is method called square. And then I create another type, my int 3 of type my int 2. For example, I create a method called cube. You see that actually, if you really look at it, there is my int 1, which has got a method called to string. There is my int 2, which is of a method called square. There is my int 3, which is of a method called cube. My int 3 is from my int 2. My int 2 is from integer normally. My int 1 is from integer as well. So the concept is any variable, any type that can be casted to integer can also be casted to any one of these types, because the all for all underlining type is integer. Again, this is not inheritance, it's just type casting. Inheritance is different. Type casting. So what do I mean by here is, let me this one keep it there. Let me create three variables where n1, let me create n1 is integer equal to some value, n2 is my int 1, let me give it as n1 my int 1, n2 is my int 2, n3 is my int 3, f1 is float 32. There are 1 2 3 4 5 variables, and I have four methods, three methods, I'm sorry, to string, square, and cube. Three methods to string, square, and cube. I can call these three methods on any one of these types. The reason is all these types can be typecasted to each other. Let's say talk about n first. Let me give it as str4. str4 equal to, the method called to string is on my int 1. My int 1 of n dot to string. Assume that square one, s1 equal to s equal to my int 1 of n to my square is not a function on my int 1, it is on my int 2 dot square. Cube function my int 3 of n dot cube. But cube function is, n is not actually, Yeah, see this. For the sake just printing them, you know the results. str4 comma s comma c. Not really bothered about s, but the important thing is how can you convert. Let's take n1. N1 has directly my int1 which has got a toString. No issues at all. S2, S1 is N1 dot, you don't get the square function. Square function is on a type called my into 2, so you need to convert to my into 2 dot square. Cube function, you need to convert to my into 3 of N1 to cube. Okay, you just print it str5 S1 and then C1. Come back here. Let's talk about N2. str6 equal to N2 dot, you don't get squares to string because to string method is on my int 1. So you can typecast it to my int 1 of to string. And S2 square method is directly on my into 2 because N2 is a variable of my into 2. You don't need to typecast anything in order to get square method. But the cube is on my into 3, so you can typecast the N2 to my into 3. Similarly, N3, you can typecast it to N3, you can typecast it to here, and you can directly call this method because it's available on N3. And if you look at the float f1, because these three methods should be converted, str8 equal to point 1 of float 1 dot to string, s of 1 for example is point 2 of f1 dot square, sc1 equal to point 3 of f1 dot cube. See this. Like this, you can typecast between different types and then achieve by calling these methods. Run this, you get all the results. This is the string. It is converted to string. If you get the type, you print it as string. This is square and this cube. This square and this cube. Square and cube. Square and cube. And this square and this is cube. You see that cube got minus because minus into minus. Minus into minus is plus, and then into minus you got minus. So you got minus result here. Okay. Like that, you can attach methods to a type, and then you can call those methods on those particular type. Okay, this is very important concept because when you look at many packages in Go, Packages use these kind of things. Packages use these kind of things. They create some methods. They create some types. The type contain. They create some custom types from the underlying type, and then yeah, this is not only stopped over here. For example, I create a type called maybe int slice, which is of int slice, which is of type integer slice. I create a function. I create a method. Is is int slice of maybe sum, get sum. So how do you get sum? Iterate. You can iterate. The range loop can be worked on this. Index comma value range of is. Okay. Sum plus equal to v and return sum. Of course, you have to check nil, but the range loop works only if it is not nil. You don't need to specially check nil on range loop because the range loop work only if it is not nil. If you are using a normal variable and all, normal loop is different, but range loop works only on nil. So this is a type called int slice. Better write it as a separate example, not to confuse. This is a customized type on existing slice, the type called slice. So what I can do, I can create a slice one equal to make of integer comma 5 elements. So slice one, I can okay. Sorry, slice one of 0, slice one of 1, slice one of 2, slice one of 3, 4 equal to assign some values. It's a normal slice. This is not int slice. Remember that it's a normal slice. I want to call this get sum method. Sum one equal to the method get sum is on type slice int slice, not on normal slice. So the slice one can be typecasted to int slice and get the sum. Similarly, I can create a slice 2 directly, make of int slice comma 5 elements. Directly I created as int slice past agent. And directly can call the method slice2 dot get sum and print 2. So you are not confined that you can create a type only on certain things. You can create type on any underlying type. You can create type on any underlying type. If you want, you can also create a pointer over here. You can also create a pointer of this. You can do many things actually. In fact, you can do many things. Okay. So both of them got 60 and 60 because we are taking the same slice. 22, 10 plus 11, 21, 21 plus 12, 33, 33 plus 46, 46 plus 14, which is 60. We got 60 right here. But the important thing is how you create a normal slice and then could be able to convert it to. But you cannot create a slice like this. That is not possible. Okay. Slice 3 is make of int 64 comma 5 and then I want to convert it into slice 3 dot get sum, which is not possible because the slice is a whole bunch, right? This slice cannot be converted to this slice. The reason is the underlying slice is this. Normal variables are different, slice is different. This cannot be possible. This does not work. No, you understand actually what does work, what does not work with some practice. But because I know that it doesn't work, because of the understanding on this, you also with some practice you get to know what works, what doesn't work, and all you get to know. Okay, this is what the concept is. Today's concept. Okay.